Continuity. To show the function f is continuous at x equals to a, these three conditions must be satisfied. Number one is fa is defined. Number two is the limit of f of x as x approaches to a exists. So the function is defined at a, the limit exists, and the limit is equals to f of a. So simply speaking, number one, f of a is defined. That means you have a solid point. So you have a solid point. So let's say we have we just draw a solid point, and then we call this f of a. So number one is you need a solid point. So need a solid point. There we have it. And then number two is x approaches to a exists. So as x approaches to a, the limit exists. So that includes the left side and the right hand side, right? So as x approaches to a from the left, so let's say we have something like that. As x approaches to a from the left, the limit exists. As x approaches to a from the right, the limit exists. And then therefore, the limit is equals to f of a. So this is just like how do we say this? The easiest way to describe this is like is like trains and tracks, right? So we starting with a solid point, and then we have tracks from the left and tracks from the right join at that point. Let's put this down. Tracks from the left and right meet at that point. So meet at that point. So let's do this graph one more time. So we start at a point. So this is my point. F of a is defined. And then the tracks from the left, that means you have a train driving from the left, or you have a car driving from the left. So let's create a path. So let's say we have a path that looks like this. So from the left hand side, so this is the left hand side. And then from the left hand side, we stop at that point. And then from the right hand side, we stop at that point as well. So you can simply just draw a line. And then from the right hand side, we stop at that point. The easiest way to describe this is you can sketch the entire curve without picking up your pencil. Let me say this one more time. The easiest way to describe this is you can sketch the entire curve without picking up your pencil. So that is continuity. We're starting with a point, and then we have a track from the left, we have a track from the right. The track and the point meet at the same place. Okay, so let's take a look at another example. So we have an orange graph. So my question is the function continuous at a? So let's take a look at this graph. Is the function continuous at a? Is this a yes or a no? The answer is no, right? So the function is not continuous at x equals to a. Why? Because f of a is undefined. Because f of a is undefined. How do you know f of a is undefined? The answer is you have an open circle, right? So you have an open circle. When x is equals to a, the function is undefined. So the easiest way to say this is you cannot sketch the entire curve without picking up your pencil. So you have to go like this. Left side, you have to stop, and then right hand side, right? You have to take a stop right over here. So that means the function is not continuous at that point. So let's move on to the next picture. So the next picture, my question is the function continuous at x equals to a? The answer is no, right? So let's write this down. The answer is no, so not continuous. So not continuous at x equals to a. Do you know why? One of the reason is the limit as x approaches to a from the left is not the same as the limit x approaches to a from the right. From the left hand side, so this is the left hand side, this is the right hand side, they do not join at the same point. So without looking at the solid point, the left hand side and the right hand side, they do not join at the same point. That means which condition is not met? That means number 2 is not met. The limit is the limit does not exist. So number 2 is failed. That means the function is not continuous at x equals to a. All right. Okay, so we have a comprehensive example. So I have a big graph. So in this graph, I have a point A, B, C, D, and E. So I want you to tell me, is the function continuous at A, B, C, D, and E? Okay, let's go from left to right. Okay, the left hand side, so is the function continuous at x equals to A? So first of all, we have what? We have as x approaches to A from the left, what is y equals to? Y is equals to 1, right? As x approaches to A from the right, y equals to 1 as well. So that means the limit as x approaches to A, let me just write the whole thing, the limit as x approaches to A of f of x, that is equals to 1. So the limit exists, right? How about the point? Where is the point? The point is f of A that is equals to 1. And let's take a look. The point and the limit, they are exactly the same. That means the limit is equal to the solid point. So coming from the left, we stop at that point. Coming from the right, we stop at that point. And that point itself is a solid point. So the conclusion is x is continuous. F is continuous at x equals to A. Okay, how about B? For B, I'm going to make a minor make a minor correction at the graph. So actually, this is supposed to be an open circle. This is supposed to be an open circle. If that is a solid circle, then I make a terrible mistake. If that is a solid circle, then this is not a function at all because it doesn't satisfy the vertical line test. You draw a vertical line, right? The vertical line only intersect the function one time. Okay, if that is a solid circle, then the vertical line test fails. So therefore, I have to put that back to an open circle. Okay, let's do let's do B. Okay, is the function continuous at x equals to B? The answer is no, because the left limit and the right limit, they do not join at the same point. So we have the left limit as x approaches to B, not A anymore, as x approaches to B from the left, y is equals to 2, right? As x approaches to B from the right, y is equals to -1/2. So y is equals to -1/2. They are not equal, so that means the limit as x approaches to B, this one does not exist. So if you go back to your notes, number 2 fail, right? So the limit doesn't exist. And does the left limit and the right limit join at that point? No. So we have f of B that is equals to -1/2. And take a look at this. They do not join at the same point. We have a does not exist and -1/2. No, they don't join at the same point. So therefore, f is not continuous at x equals to B. How about C? How about C? Let's put the C down here. Let's put the C down here. Let's use screen. So x equals to C. All right, so as x approaches to C from the left, what do we have? Left hand side, we have a -1/2, right? And then right hand side, we have a +2, so they are not equal. So that means the limit as x approaches to C from either side, just x approaches to C, you don't need to say either side. This one does not exist. I should erase the equal, so does not exist. Okay, so number 2 is fail, so that means the function is not continuous. Let's check the last point anyway. So this is f of C, right? So that is equals to 1. We have a 1, we have a does not exist. Nope, the limit is not equal to 1 at all. So therefore, we say f is not continuous at x equals to C. It is just that simple. Okay, moving on, we have D and E. So D, what do we have for D? So D, as x approaches to D from the left, x approaches to D from the right. From the left, what do we have? We have y equals to 2, y equals to 2. All right, so limit as x approaches to D of the function, this is equals to 2. Well, is that means, okay, so this time number 2 is satisfied. Is that means the function is continuous at D? Of course not, right? The D is an open circle. What does that mean? That means when x is equals to D, the function is undefined. Let me say this one more time. There is an open circle. Again, there is an open circle when x is equals to D. That means when x is equals to D, the function is undefined. So f of D is undefined. I'm sorry, that is not equals to 2. So at the end of the day, what do we say? We say the function is not continuous at x equals to D. All right. And then the last one is clearly not, because at x equals to E, there is a what? There is a vertical asymptote, right? So let's complete this. So for E, as x approaches to E from the left, x approaches to E from the right. So from the left, we have negative infinity. The right hand side, we have positive infinity. So the limit as x approaches to E, that is does not exist. And beside, f of E is undefined, right? Because x equals to E is a vertical asymptote. So that means the function is not continuous at x equals to E. So it is just that simple. Alright, so that is the end of this video. I will catch you all in the next lesson. Signing out.